read things, whether or not it's about the lottery, at a gas station, or maybe it's about the statement that you've gotten from your investment firm. You take a look at it and you want to think, okay, how likely is the chance that I'm going to make money on this stock? What were the returns on my investments last year? It's the understanding of what's going on with your finances. So today we're going to start with some interesting stuff, and dice are one of the things that they're going to talk about. So I'm going to show you a couple of die here, and generally die are things that you've probably worked with as you've come up through school, because we don't consider using die as gambling. I always think of these as we play Yahtzee and die. The book will mention cards, and every once in a while there are some people that have never played cards before, and I'm not going to call anybody out on that, but that makes the math a little harder for you, because they do expect that we do know there are 4 suits, that there are 13 cards in every suit, and that we do know what cards are in those suits. So, is there anybody in here who hasn't ever seen a deck of cards or played cards before? Okay, and you can keep it private and come and tell me later. But with the die, what they talk about is what's the probability when you throw 2 die of something happening. And so instead of having you write out all those possibilities, I just copied off all the possibilities that can happen, because the visual helps a lot. They're going to ask us, what's the probability that when you roll 2 die, you would have a sum of 3? And I don't want that to take forever for you to figure out. You look at it, oh, well, a 1 and 2 and a 2 and a 1, there's 2 of those. How many total would there be? Well, when you're rolling 2 die, those 6-sided die, the fundamental counting principle says 6 times 6, so it would be 2 out of 36. But for the tougher ones, I think it would be helpful to have a visual of all those outcomes. And we won't give you anything on the test that would require memorization of this. You would never have to memorize this. You just have to have a feel for what happens when you roll a couple of dice. That's it. So, now, probability. It says the objective. We want to be able to get out of here today doing some stuff with probability. We want to find the probability of an event using theoretical, which means, well, this is the way we know it should happen. For instance, if I take a penny and I toss it up into the air, what is the probability that heads will be showing when it's on the floor? 50%, 1/2. Now, do you know that because you went home last night and tossed a coin 3,000 times and half of the time you got heads? No. We know that because we look at the coin and say, well, it's going to land on one of the 2. That's what we have. It's 1/2. In fact, there's a Russian mathematician who was put in prison, and they talk about how he heroically tossed a coin most of the time that he was in prison, and he millions of times he tossed that coin. It does not come out perfectly to 1/2. It doesn't. But theoretically, we know it should. So we should get about a 1/2. And his would be considered experimental because he was actually doing the experiment and trying to find out, is it going to be perfectly 1/2? Simulation methods would be, hey, we're all broke, we don't have any coins, and we want to figure out a way to use something else and want to figure out what would happen if you toss a coin into the air. So we could just grab a thick piece of paper and say, okay, this has a number on it. Let's have that be heads, and let's have this be tails, and we'll just throw it up in the air, and we'll use that to simulate it. Is it going to be perfect? No, it's not going to be perfect because it's a piece of paper. It's got this floating. It doesn't have the weight to it, but we could use that to simulate. Now, what I'm going to show you today is that your calculator actually has a program on it to help you simulate different trials for something. So the getting ready here says in a probability experiment, you fold an index card slightly off center as shown at the right. And I didn't have an index card, but I thought they're kind of small anyway, so I grabbed this. And so they don't want me folding it exactly in the center. So something that's a little off. And then it says you drop the card from a height of several feet. What outcomes are possible? No, it could land like this. Could land like this. Or it could land like this. Any others? It could. Chances are pretty low, but it could land like that. And it could land like this. So, what do you think is most likely to occur? Big flat one? This way? So that, as people are nodding their heads, I think these are probably the two most likely that people see, this one right here, and then this one. So some people are thinking it kind of depends on how you drop it. If you just drop it like this, well, it's going to fall down flat and it's going to end up like this. But some people are saying there's going to be air resistance. And so if I drop it with air resistance, it's probably going to flip it over and it's going to land this way. Land flat. Just like this. How's it going to land that way every time? No. One year I tossed it up and it landed like this on the floor. Like, what are the chances that's going to happen? But they do. So there would be probabilities that we could see if we actually did an experiment using that card and find that out. And that's what we want to be able to do, is figure out what is the probability, whether or not it's theoretical, experimental, or if we're just using math to get it, you know. And most of the math that we do is going to be theoretical. In a perfect world, this is what would happen. So our essential understanding, probability runs from 0 to 1. And yes, we often talk about that in terms of percentages, from 0% to 100%. So whether or not we're going to use fractions to say it's from 0 to 1, or we use percentages from 0 to 100%, that actually I think is totally up to you. I think the book generally gives both the fraction answer and the percentage answer, but we want to keep it as exact as possible. So otherwise, the probability of an event, it's just a number between 0 and 1. They're the fractions. I tend to just leave it in fractions, and that's because once you start doing math with it, you have a chance of making a mistake. You know? So unless the problem says give the percentage, I'll generally just leave my answers as fractions in simplified form. So how do we find experimental probability? Well, there's an experiment. Either you performed it or somebody else did. You know, there has to be an experiment. And any percentage, any probability is always about what we want to happen over the total number of things that can happen. And they explain this as the number of times the event occurs. What are you trying to keep track of? You know, maybe you write down, these are the things that can happen when I toss this in the air. It could land flat. It could flip over in a triangular pattern. It could land so that it's vertical. But that actually could happen two different ways. And then it could land on the short side. So you'd write all of those things down and you'd say, well, those are the total number of things that could happen. What do I want to happen? Well, there's only going to be one of those out of the total. So finding experimental probability sometimes involves us doing the experiment. But most of the time, since this isn't a book, somebody's already done the experiment and they just want us to use the numbers to figure out what's the probability. So of the 60 vehicles in a teacher's parking lot today, 15 are pickup trucks. What is the experimental probability that a vehicle in the lot is a pickup truck? We already did the experiment. What do we want? Pickup trucks. So that's going to go on the top. What's the total number of things that could happen? Well, there's 60 different vehicles. So we look at that and say, hey, wait a minute, that would go in there 4 times. And remember, on the MCAs, the last few years, they have said it's going to be all multiple choice by whenever. And and it never has. They've always had at least one of these gridded response problems on there. So as I mentioned before in an earlier section, if you're going to put your answer on here, you need your answer all the way to the left or all the way to the right, never in the middle. So if I have 1/4, what I'd want to do is put 1/4 and then fill in 1/4. Because if I know the answer, I want to get the points for it. Or you go all the way over to the left-hand side and fill it in. But you cannot put it smack dab in the middle, or their computer system will grade that as wrong. So we know how to do the math. Make sure to fill it in so that we get the points for it. So the next one says a softball player got a hit in 20 of her last 50 at bats. What's the experimental probability that she will get a hit in her next at bat? And you guys are going to do that one. That's kind of silly, but I'm going to go ahead and give you a candy partner for this one. You've probably already done with it. Just so you can talk through it. You reduce it, fill in the grid. That way you can check in and welcome with a partner or partners. All right, candy up in the air. Find your partner. Go talk to them about what you had for an answer, what they had for an answer, and how you filled out your little grid thing. Oh, yeah, the strawberry. What's the answer, everybody? So we could also put it to the left. Just never right in the middle. So again, experimental probability, generally they're not going to have us do the experiments. They'll just give us the numbers. We have to realize, hey, the numbers are already there. And every once in a while what they'll do is they'll actually pull data out of something that's already documented. You know, think about all of the milk and cheese data we had the other day. You know, they'll take those numbers and use those for probability, and that's okay. While it wasn't an experiment, it's recorded. And that's what matters when we're trying to find experimental probability. Do we have some data that's already collected that we can use? Sometimes actual trials are difficult or unreasonable to conduct. So if it's really expensive, what people will do is tend to come up with a way to mimic what it is they want to happen. So in these situations, we can estimate the experimental probability of an event by using a simulation or a model of the event. And yeah, I'm gonna give you a second here to go back and grab your graphing calculator because I forgot to tell you to take those with you. Because I'm gonna show you how we can simulate experiments by using your graphing calculator. And where we find it is not going to be any kind of shock to anybody. Oh, there's probably some people that need to borrow one down there. Totally forgot. With the calculators. Yep. Oh, have one already. Anybody else need to borrow one? All right, everything that we've needed to deal with this chapter so far has been where on your calculator? Tell your partner, where have we been finding everything that we've needed? Math probability, yeah, math probability. This is not going to be any different. But what we're going to do here is read this and figure out, well, how could this be simulated? And it says we've got a multiple choice test. Each item has 4 choices, but only one of the choices is correct. How can you simulate guessing the answers? What's the probability that you'll pass the test by guessing at least 6 of 10 answers correctly? Now, I certainly could have given you a test on some topic that nobody knows anything about, or maybe just made up some questions that didn't have correct answers. And said, here, just everybody fill these in. We don't know anything about it, just A, B, C, D, all of these. And we could run an experiment seeing what it is that we get. But that's going to take a long time, you know, and if we have a way to do that quickly and get those responses, that would be better. So what we do is we use a little generator inside your calculator called randint. That's random integers. And integers are the positive and negative numbers with no decimals and no fractions. So -3, -2, -1, 0, 1, 2, 3. But what we have to do is be specific with the calculator and tell it. First of all, how many right answers or choices do we want there to be? And one of them is correct. But then we put a comma in there because it needs more information. It needs to know, well, how many choices do you have each time you run this trial? And each one of these items has 4 choices. So we're going to do 1, 4. That tells the calculator 1 right answer out of the 4. And then we have to figure out, well, how many total times was this happening for each one of these trials? And what we were looking at was 10. We wanted to know out of 10 answers correctly. Now here's the one thing we have to do. We have to make up which one of those we will use as the correct answer. We could say any ones that we see means they got a correct answer. We could say any 2s that we see means that it's a correct answer. Any 3s, any 4s, totally up to us. I'm going to say a 1 is a correct answer. And so what we would do is we would keep track of how many times we wanted to know guessing 6 of 10 answers correctly. Now that's at least. So we could have 6 ones, we could have 7 ones, 8 ones, 9 ones, or 10 ones. And you'd have to do this enough times to make it worthwhile. So with something like this, we might want to do 20 trials. And just keep track with the tally how many times out of that 20 this works. So we might have how many 1s over here, and over here, how many trials. So just a tally to keep track of it. And of course, it's under probability. So math, probability, number 5 down there is random integer. So we're going to grab that little bugger. And we're going to tell the calculator 1, comma, and the comma is right above the 7 button, 4, comma, 10. And parentheses to finish that out. Oh, great, they changed it up. The calculators. think would be okay with 1, 4, 10. Yep. Wow, why did they do that? That was so nice the way it comes out now. Anybody else have something weird coming up? That's something goofy? What do you think? Yeah, and where it says lower, put 1. Where it says upper, put 4. And then 10 trials, so N is 10. That was really nice. That makes it really hard to figure out what it on record is. No one did that pictures then too? With that? Okay. Yeah, it's almost like it's using computer language to get you to do that one. So now I hit enter, and I'm looking for ones. I want 6 or more ones, and I'm going to have to arrow over so I can see. Let's say I've got 1, 2, 3 on the main screen, 4, 5. That's a trial. It wasn't a success. I didn't get my 6 or more ones. So now if I just hit second, and actually maybe I could just hit enter again. I think these are programmed to just hit enter again. Yep, just keep hitting enter. Is yours being goofy again?
Yeah, we'll have to scroll over so I can see through.
Oh, for goodness sake. So all you can see is the ones that fit on the screen.
Yeah.
Oh. Sometimes they make changes that are really nice and others they don't.
Well, voice is just gonna say something.
You're actually seeing them all. Your screen fit the whole thing. Got all 10 of them right there. Okay, well that's a nice thing. You could see them all. We have to scroll over. Alrighty. So keep going. Count up any as successes, but keep track of how many trials you've had as well. So let's see what I have up there the second time. Nope. Nope. Almost. Has anybody had a success yet? 6 or more ones? Did you? A few people. Wow, it's a lot of trials to go through without one success yet. Ah, 6 of them on the last one. Is there anybody that would have to write down 0%? You did all your trials and not a one of them had. Yeah, there's a couple of people. None of them. But think about what we were trying to figure out. What we were trying to figure out was if they knew absolutely nothing and they just guessed, what the probability would be that they would get 6 of 10 answers correct. That's gotta be low. It has to be. In mine, I only had 1 success out of my 20. That would be what I would have to write down for my experimental probability. How many people had 1 out of 20? Yeah, I knew that one would probably show up a lot. How many people got 2 out of 20? Anybody get anything higher than 1? 2 people? Allie? How many? 3, and you're not done. Oh my goodness. 5 successes?
Successes.
Oh, okay, yeah. So it's going to be low. We know that. Now, this one down here says, in problem 2, what's the probability of passing if a passing score is 50% or better? So we wouldn't use 6 ones, would we? What would we use? 5. So if we saw 5 ones, but we don't need to do another one. I mean, once you find where it is, this is not a tough program to use. But again, I'm looking up there thinking, maybe if I'd have chosen 2 as my correct answer, I might have had a higher probability. You know, but you can't do that when you start. When you start, you say, this is what I'm going to use, and you stick with it all the way through. And then whatever happens, happens. So that's going to be our random way of generating this. Because again, some things just take too long or they cost too much money to actually do. The set of all possible outcomes to an experiment or an activity is called the sample space. So in the experiment we just did, the only numbers we were going to see up there was 1, 2, 3, and 4. That was it. Those are our sample space. Either we get a 1, we get a 2, we get a 3, or we get a 4. When each outcome in that sample space has the same chance of occurring, the outcomes are called equally likely outcomes. That's what the calculator is supposed to do for us. There's an algorithm in there, a computer algorithm that tells it just to randomly generate numbers. And that's what it does. Now, some people will argue it's not too random because there have been times when I use my TI-84 Plus up here and other people that have TI-84 Pluses see the exact same numbers that I do here. And it's just because it's the first time you used your calculator and somehow it was synced with mine. Maybe I cleared my memory and started over and it's generating the same things because it's a computer. It's what it does. Everybody's little computer is the same. So it could be that somebody in here had the exact same data that you did as you were going through there. But it's not supposed to. It's supposed to be a random integer that generates those out. So theoretical probability. That's what I was talking about before. In theory, we know it's supposed to happen that way. If you have a die and you throw it and you want to know how many 5s, what are the chances of 5 is going to show up. You really want a 5. Well, there's only one 5 on the thing, and it has 6 sides. So it's going to be 1 out of 6. Now, that doesn't mean you sat there and threw the die 200 times and kept track of it, and the probability came out to 1/6. That's experimental probability. Theory means this is what we know should happen. So if a sample space has n equally likely outcomes, and an event A occurs in m of those outcomes, then the probability, the theoretical probability of the event, is m over n. But you know what? With any probability, I just think what I want over the total. If what I want is a 5, I count up how many 5s there are on the die. There's only 1. Out of the total, there are 6 numbers on the die. So 1 out of 6. So sample space is all the outcomes that could happen, a 1, 2, 3, 4, 5, or 6. And inside there, we have what we want, which is event A. So this says finding theoretical probability. What is the theoretical probability of each event? Oh, rats, and I didn't even look at this problem before I got started. I accidentally used 5. So there's 1 5. The little circles on the die are called pips. I always think that's so cute. So the 5 has 5 little pips on it, and we have 6 different outcomes that could happen. Now, B brings us to those little sheets, and at least one of you should probably be in the seat that you were in before. So this says, what's the chances of getting a sum of 5 on one roll of standard number cubes? So you grab your little sheet, and you'd see 1 and 4. That's going to make it happen. 2 and 3, 3 and 2, and 4 and 1. And show your little sheet to your partner and show them where those occur. Because not everybody has them. There's one of the 4. So 4 and 1, 1 and 4, 2 and 3, 3 and 2, Everybody notice they're kind of on a diagonal? Yeah, that happens every time. So we have 4 of them out of how many total on this little sheet? 36. So that would give us 1/9. With your partner, or partners, like I said, somebody probably has one of those little sheets sitting on their desk right now. Find 3A. Make sure you talk to your partner about it and that it makes sense. What did everybody find? What's the probability that you're going to get a sum that is an odd number? Half. 50%. Half. Without counting. Tell your partner what the probability is, because we're talking about this even or odd. The probability of getting an even on that list of 36, how it comes an even sum. So if you're not counting, how do you get 1/2 for B? When you add 2 numbers together, how many different things can happen? Don't you just have a choice of either it's going to come out odd or it's going to come out even? So if it's not odd, it has to be even. So if half the time it's going to come out to be odd, the other half of the time it has to come out to be even. Does that make one more likely than the other? What does it make them? The same probability. They have the exact same probability. And I know it seems like it's kind of silly, but when I was scheduling this out, I thought, you know what, it's okay that we go a little slower every day. We had a few times there where we were crunching before Christmas. You guys deserve a break. So 43210 beyond just what we've covered today. All right, numbers are looking good. Tell your partner thank you for the chat. And it's also, the other part of planning this out is, in this class I have quite a few 9th and 10th graders, but I know in my 5th hour it's almost exclusively juniors. So sometimes this is the first experience with probability for people, and I don't want to go too fast and zip right past people. So there we go, a little bit of probability, experimental, theoretical. Randomly generating. Thanks.
I was going to we got test mode.
Yes, we did. Hang on, I'm just thinking I'm recording right now.